All right, this is a quick little review of our quiz and how we got to each of those answers. That way you can kind of see where you might have gotten tripped up or had some trouble. So the keys are: read the directions carefully for each question. You must show your work for each of the problems. Always write your answer in simplest form. That's for number 1 and 2 for your ratios. And don't forget your units. That's going to be for question 3 and 4. So question 1 says, an animal shelter has 36 kittens and 12 puppies available for adoption. What is the ratio of puppies to total animals? So what happened is, for a lot of us, we just took the two numbers in the problem, shoved them into our answer, and thought we were done. We didn't read carefully for what the ratio was actually asking for. The ratio asked for the number of puppies, 12, to the total number of animals. Well, if there's 36 kittens and 12 puppies, that means there are 48 total animals. So 12 over 48. But then the last part is, make sure you write it in simplest form. Remember, a ratio, we often write it as a fraction to remind us that we have to simplify fractions. Okay, that's different from a unit rate, and that's why we've been practicing. Simplifying a fraction just means, what could they both be divided by? In this case, 12 and 48 could both be divided by 12, and I get 1 over 4. And you could write it with the word 2, or you could write it with the colon. Either one is fine, but your correct answer is 1 over 4, 1 to 4. 1 puppy for every 4 total animals. Question 2. On the first day of school, Mrs. Teasley's class brought in the following: 6 cans of fruit, 4 cans of beans, 7 boxes of noodles, and 4 cans of soup. What is the ratio of cans of fruit to cans of soup? So we're just pulling out the necessary numbers from the problem to write it as our ratio. Cans of fruit was listed first. That's 6. Cans of soup was listed second. That's 4. So we have a ratio of 6 to 4. But a ratio always has to be in simplest form. So we have to think about, what can 6 and 4 both be divided by? Well, they can both be divided by 2. And we get an answer of 3 over 2. Or 3 to 2. Or 3 to 2. Whichever form you wanted to write your final answer in. But it's simply a matter of pulling out the necessary information to build our ratio, and then we simplify it to get to our final answer. All right. So, scrolling down our page here. Question number 3. And here's the big part. And it was the exact same directions on our review. It was the same directions when we practiced them in class. I even drew the bar right there on the page for you. But it says, complete a bar diagram. Okay? We've got to get out of the habit of thinking that just because we get an answer that we're magically done with the problem. In math, you have to be able to back up your answer. You have to be able to demonstrate to somebody else how you got to that answer and be able to find different ways of displaying that information. So question 3 asks you to use a bar diagram. So here was the expectation. Preston drove 240 miles on 6 gallons. So 240 miles with my units is my total amount. And that was for 6 gallons. But I want to know how much it is for just 1 gallon. So I'm going to divide this up into those 6 gallons. It was 6 gallons worth that got me 240 miles. So I broke it up into 6 pieces. Each of these represents 1 of those gallons. So we're visually showing somebody how we took that 240 miles and broke it up for each of the 6 gallons of gas that was used, just like we practiced in class. The picture also helps remind us what we need to do our calculation. We took 240 and we divided it into 6 pieces. Well, 240 divided by 6 is 40. So each one of these 1 gallon sections is equal to 40 miles. But when I was checking this problem, I was looking. Did you have 240 miles along the top? Did you break it up into 6 equal parts? And were each of those labeled as 1 gallon? You didn't break 240 miles up into 40 miles. Okay? We didn't know 40 miles was the answer until we got done with the problem. We broke it up into 6 1-gallon sections and got an answer of 40 miles. Number 4, and we've practiced this one a lot. We've done several of these together. It says, determine which jar of jelly is the best deal. So for each option, we are going to write it as a rate and then show how you change it to a unit rate. Again, just writing a division problem or just circling an answer or just telling me which one's the better deal, that's not going to get you the points. And we've talked about this repeatedly in class. You have to show the work to back it up. This was a 5-point question. You got 2 points for each of your rates, 2 points for each of your unit rates, and then 1 answer for telling me which one is the better deal. You've got to back it up with work and show how you got to that answer. Okay? So I start with my first one. Money always goes on top. $3.19 for 16 ounces. Remember, in order to determine which one's the better deal, we need a unit rate. So I want to figure out how much it is for 1 ounce. Remember, to make it a unit rate, we always divide by our denominator. In that case, I get 0.1993. Okay, remember, we're going to get long decimals in these. That's okay. That's why we spent a whole lesson practicing our rounding. It's money, so we're going to round to 2 decimal places. So we look at that very next number. That next number is a 9. That says we're going to round up. So 19 rounds up to 20 cents. So jar number 1 is 20 cents per ounce. So now we look at the second one. $5.79 for 32 ounces. But again, in order to compare them, we need to make them the same size. So I'm going to turn this into a 1 ounce package. Well, to make it a unit rate, I need to divide by my denominator. And there I get 0.1809. And then it's a longer decimal after that. Okay. So I'm going to round it off to 2 decimal places. So I look at that next number. A 0 says we're going to round down. And we're going to round down to 18 cents. So here's where I wrote each of them out as a rate, including my units. Here's where I wrote each of them as a unit rate, including my units. And now that they're a unit rate, now I can compare them together because now they're the same size. So the first one was 20 cents per ounce. The second one was 18 cents per ounce. The better deal is which one is the lower price per ounce. In that case, the 32-ounce jar is less expensive. It's 2 cents less per ounce, which makes it a better deal.